Welcome to wpi.edu/listen, your go-to audio news and podcasts for all things Worcester Polytechnic Institute. After you've listened in, check out our other episodes and dive deep into the exciting news stories shaping the WPI community. Friday, May 22, 2026. New Worcester Polytechnic Institute research could give used electric vehicle batteries a second life as higher performance materials. $1 million. Department of Energy supported project builds on WPI's leadership in battery recycling research and aims to strengthen U.S. battery supply chains, lower recycling costs, and improve sustainability for the electric vehicle industry. As demand for electric vehicles and energy storage systems accelerates worldwide, researchers at Worcester Polytechnic Institute, WPI, are developing a new approach to lithium-ion battery recycling that could help transform how critical battery materials are recovered, reused, and returned to the manufacturing pipeline. Supported by a $1 million award from the U.S. Department of Energy, the project, led by Professor Yan Wang, William B. Smith, Professor of Mechanical and Materials Engineering, will develop a one-step molten salt upcycling process that transforms spent nickel cathodes into high-performance material for next-generation lithium-ion batteries. The approach would reduce the cost, complexity, and energy demands of current battery recycling methods, while increasing the value of recovered materials. Lithium-ion batteries are essential to the future of transportation, renewable energy, and modern technology, but the rapid growth of battery use also creates an urgent need for more sustainable and economically viable recycling solutions, said Wang. This project focuses not just on recovering materials, but on upgrading them into higher performance battery components that can directly support the next generation of electric vehicles. After battery discharge, shredding, or dismantling, and separation of cathode and anode components, the team's process converts mixed spent nickel lean cathode materials into nickel-rich single-crystal cathodes, such as NMC 622, a necessary component in many of today's lithium-ion batteries. Nickel oxide, manganese oxide, and cobalt oxide are used as source materials to upgrade blended cathode waste into advanced battery materials with improved capacity and stability compared to conventional commercial materials. Designed to work with both pure and mixed cathode waste, the process eliminates additional sorting and separation requirements. The project also addresses a growing challenge within the battery industry: the mismatch between the materials recovered from older batteries and the newer high-performance materials needed for modern electric vehicle batteries. This work supports the development of a more circular battery economy, Wang said. Instead of treating spent batteries as waste, we are finding ways to convert them into materials that may perform even better than the originals. That has important implications for sustainability, manufacturing resilience, and the future competitiveness of the U.S. battery industry. The project builds on years of pioneering battery recycling and materials research led by Wang, whose work has focused on developing more sustainable and economically viable solutions for recovering and reusing lithium-ion battery materials. Wang's research has advanced novel approaches for direct recycling and upcycling of battery waste, helping position WPI as a leader in next-generation battery sustainability and circular manufacturing technologies.